Let's see what we have here. So it says the Greek letter sigma, or this big sum sign, indicates the sum. So we use the limits, the upper and lower bounds, to indicate how many terms you're adding up. And we always write the limits above and below the sigma sign to show the terms. And so let's go here. So we're going to start here at n equals 2. And we're going to end here at n equals 6. And every term for our explicit formula is right there. So let's work the example. So this tells us that we're going to sum up the term for n equals 2, and n equals 3, and n equals 4, and n equals 5, and n equals 6. So we're going to sum them up. So if n equals 2, we have 2 squared, or 4. When n equals 3, we have 3 squared, or 9. And when n equals 4, we have 4 squared, or 16. And when n equals 5, we have 5 squared, or 25. And when n equals 6, we have 6 squared, or 36. So that S sub n is going to equal 4 plus 9 plus 16 plus 25 plus 36, which is 90. All right. Example number 2. Find the sum of the first 100 natural numbers. So it's going to maybe blow your mind for a minute, but let's think about the first 100 numbers. So a sub 1 is equal to 1, right? What's the 100th number? That's equal to 100. So if we know the first and the last numbers, we get to use that formula that told us S sub 100, because n equals 100. So we're doing the first 100 numbers. It's equal to n over 2. Well, actually, I do kind of like to do the formula first. So S sub n is equal to n over 2 times the first term plus the last term. So then S100 is going to be 100 over 2 times the first term plus the last term. First term is 1, last term is 100. And so that is 50 times 101, which equals 5,050. That was pretty cool, but I have to say it's pretty rare to know the first and last numbers. And so the next example is actually an infinite sequence, but it wants us to find the sum of the first 15 terms. So we know n is going to equal 15. We know the first term, but we do not know the 15th term. And I suppose if you were really driven, you could actually just calculate the 15th term, but it's easier to use the formula that S sub n is equal to n over 2 again, 2 times the first term, so 2 times a1, plus n minus 1 times d. All right, so what is d? If this were a sequence, 2, 5, 8, 11, every time we take a step is plus 3. So d is equal to plus 3. All right, so for this particular arithmetic sequence and series, the general rule is going to be S sub n is equal to n over 2 times 2 times a1. So the first term is 2. So 2 times 2 plus n minus 1 times d, and we just figured out. Right, so then if we want to find the 15th, the sum of the 15th term, S sub 15 is 15 over 2 times 4 plus 15 minus 1 times 3. So this ends up being, again, I'll go through this in class, but the final answer ends up being 345.